Now let's put what we have learned into practice. So I have opened up my PG admin interface, and when I open this up, it asks me for password. This password is the super user password you entered when you install Postgres. So and at that time, I asked you to take a note, write this down. Hopefully you did that. So now it's time to enter this password. And I'm going to click OK. Once I enter here, you see the servers. I'm going to open this up and I see a local host I defined before. I click on localhost. It takes a while to expand. And as you can see, there's under localhost, which is the database running on my machine, stored on my hard drive. There's a list of databases on my hard drive. And here we have the first one, which is called Postgres. This is the default database created by Postgres. As I said, most DBMS will create a default database when you first initialize it. As a data scientist, you are not you're not supposed to create or drop database. So I'm going to just let it go. But you should have the idea of create and drop database statement, and you should know what database is. Now, when I right-click on Postgres on this the database name, I see different options, right? What is most relevant to us is I'm going to click on the query tool, which will bring up an interface here. I'm going to copy a bunch of SQL statements here that I'm going to use. As you can quickly see, I have a bunch of create and select statements. Now, since I have multiple SQLs, what I can do when I want to run certain SQL is to highlight this SQL statement and click on the execute button. Once I click on this, you can see that query return create table finished. And you can also see that I can create. Let me open this up first. As you can see, under Postgres, there's a bunch of list objects, and the schema public, there's the tables choice. Now that you can see, I just created an instructor table with 2 columns. What I'm trying to show you here is the naming convention. So like we said before, column names should not start with a number. It should start with a what? Underscore or alphabetical character or letter. So here I try to run this and I get an error. DBMS is telling me syntax is wrong. I cannot have a column name like this. Now, let me add a double quote around this 2020 sales. What's going to happen? SQL is properly table is properly created. However, if you look at the table here, it's not showing up because while you create something here, it's this table definition is not refreshed. So if you want to see it, you need to right-click on table and click on refresh. And now you can see there's this naming convention table, right? And the name is not sensitive, case sensitive. I already get a naming convention table, right? So what if I'm trying to create another table with the same name, but all uppercase? It tells me naming convention already exists, right? So we also mentioned about primary key. Like here, the instructor name is a primary key, right? We also mentioned what's a wrong way of defining a compound primary key. You can have, if you have a compound primary key, like in this table, the primary key is both student ID and the course ID. Then the right way of writing is to use a primary key table constraint with both column names defined. You cannot add a primary key after each column, after both columns. Excuse me. So this is what is wrong. And how about this? Now this one works fine. And as soon as you right click on tables and hit refresh, you will see the registration table. You may also notice that I have put a lot of semicolons. Semicolons used to separate SQL statement. And when you try to separate SQL statement, see this drop? I can select all three and run at once. With this semicolon, PostgreSQL will understand each statement before semicolon is one statement. If I don't have the semicolon and I try to select both and run, there's an error because Postgres will think the statement is like this. Of course, this is wrong. However, once I have a semicolon, Postgres understand these are two and three separated statements. Then when I run it, all three tables are dropped. And now that I right click on tables and click on refresh, there's no table existing anymore. Okay, so this is for how do you run multiple statements in the same time in one batch by adding semicolon. I always recommend you add a semicolon because sometimes you may want to run multiple statements without semicolon. You may accidentally make mistakes. So it's always recommended to do that. Also, let's do some insert. Create this table, instructor again. And let's insert with one statement. And this statement, we have the affiliation in front of name. So now I finished running both. How about I right click on tables, click on refresh, and now we see the instructor table. I can also right click on instructor table and try to view the data. So you can see that Obi-Wan Kenobi and Qui-Gon both are properly inserted, right? And where were? And let's get back here. And if I do a default insert, I'm picking these two statements and do a default insert, both finished. Now let's go back to here and refresh. I can see that I have Darth Vader and I have Anakin Skywalker. Okay, so much is for insert, but how about we have a long name, and you can see affiliation is a chart 10, right? If you have a chart 10 and I'm trying to insert a 20 character string into here, what will happen? DBMS telling me value too long for type chart 10, right? Now, if I want to insert an integer, oops, I accidentally. You can successfully insert this decimal into an integer, but what will be the result? That's a key. Let's see what data is inside here. You can see that it is 123 instead of, oops, 123.45, and you can clearly see there's no warning, right? So you are losing your accuracy, your data accuracy, but you are not getting any warning. That's the one thing that I have been warning you guys to pay attention to, because I see this all the time. Okay, I dropped this table. Now let's do some selection. I'm selecting this affiliation. See, that's here. Right now, I'm selecting affiliation first. So you get Jedi sys first, followed by instructor name. I can also do a select star. Select everything. And by this time, instructor name comes first because this is the default order. I'm selecting instructor name with a star. So you can see instructor name show up twice. The first comes from this from this instructor name column defined, and the second one comes from the star. Then we also have this where clause. Remember, we have four rows. One of them is Darth Vader with this, but because we have this where clause, we are only selecting 3. And now we have, how about select distinct? We have 3 Jedi, but here we only see 1 because we have a distinct definition here, right? So Jedi only shows up once. How about this famous? This is a test SQL. As you can see, because we have 4 rows in instructor table, this is a test, shows up 4 times. But of course, if you have a select distinct, you only get 1 time. And I'm going to just show one more affiliation. You have 3 Jedis and a D and a this. But then once you have the distinct, you have 1 Sith and 1 Jedi. This is not select execution, but a select with order. So let's come back here. I just want to show you select star. As you can see, this is the order, but they are not in particular order. What if I want to see all Jedis first, followed by all Sith? And within Jedi, I want to see instructor names ordered too. So, oops, I think I forgot to select something. So here you have all the Jedi, starting with Anakin, O, and Obi-Wan. O is before Q. So this is what we are expecting to see. And we can also have this order by 1 and 2. Column 1 is, of course, Jedi, and the column 2, of course, is instructor, and the column 2 is descending. So Q comes first, then followed by O, followed by A. Now, as you can see, I'm writing all this in one line. You can basically write your SQL statement as wild as you want. You can put all this together, like there's no naming convention. Keywords, SQL keyword, and SQL and column name, table names are not case sensitive. So you can write whatever you want to, like instructor, if I want to put the TOR and the name, NAME, these are all perfectly fine. And you can put everything in one line without breaking it up, and all this will still work. However, comparing to this, wouldn't that looks better for human readers, right? So this is what I mean by you can write as wild as you want. However, you should keep a naming convention. For example, here I will try to do is I'm going to try to use uppercase for keywords. I'm going to use title case for my column name, and I'm going to have proper line break. Line breaks breaking up different clauses in one statement so that it's easier to read. Also, like in create statement, when I have a parenthesis, I'm going to use proper indentation so that it's easier to identify. Later on, when we learn subqueries, you will run into a whole bunch of queries, query inside query, parenthesis inside parenthesis. At that time, that's when you really need indentation, because proper indentation helps you to identify which query belongs to which part. So this is when why I emphasize you should always follow good convention, naming convention, or writing convention. Usually when you go to actual work, most companies will have their requirement for convention, for SQL convention, how you want to write your SQL. But in most cases, these are not strictly followed. Still, writing nice to read SQL will make your job easier, make other people's job easier, and will actually make other people feel good about you and increase your performance score. Make people believe you know what you are doing. So try to form your own convention. And once you get into a new job, trying to understand what their convention is, and try to follow it as much as possible. So how about data type? So we have this instructor, we have the varchar and the char. We have an instructor name. I'm going to create these two tables with a course name as a varchar, course ID as an int, and instructor name as varchar, and tuition as decimal. I want to insert this 12.34 into this int and insert this integer into tuition. What's going to happen? You guys, this is what we see just now. The 12.34 becomes 12, and 50 becomes 50.00, and it's 00 because it's numerical. The scale is 2, right? Now, how about digital precision? Remember, it's a 7.2, right? That tuition is decimal 7.2. So this here, 1, 2, 3, 4, 5, 6, plus this 2 scale is actually an overflow. A field with precision 7 scale 2 must round it to an absolute value less than 10 to the power of 5. So this is the overflow we talked about. But how about, oops, how about precision issue? So we have 6, 7, 8 as the digital point, the decimal digits, 3 decimal digits with only 2 allowed. Let's insert. And you can see that the result, the SQL is supposed to work successfully without any warning issue or warning message, right? But what's the result? The result basically gives us 6, 8 because 6, 7, 8 is rounded to 6, 8. So this is actually a loss of accuracy, but we get no warnings. Now, how about comma? How about inserting with quote? And how about inserting a character? Now, inserting a character into tuition field will definitely fail. I don't think that anyone have any question on that. Inserting a string, a number with a comma in that will also fail, right? Because this comma, SQL interpret this as a separation, as a part of a value list. So SQL thought it was 50, followed by another value of 000. Because of this, the insert failed because the SQL thought that we have an extra value. So what the takeaway is, you should not have this comma. But how about I have a single quote? Now, it will actually work. You will see this 500 shows up. Apparently, Postgres has some artificial intelligence that it understands that this value is convertible. It's possible to convert this into a number. So it does that, but you should not do that. You should avoid writing quoted values. We will talk about this in the future session. Why you are not supposed to do that? But fundamentally, it's because as a SQL developer, as a data scientist, you should write your code as clear as possible. You don't want to let other people or the DBMS guess what you are trying to do. And the writing proper data type matching is a part of this requirement. And here it's a simple one. No double quote, it will fail. And as you can see, the error is actually because we have a double quote here, right? But the error message says syntax error around the parenthesis. So this is the one issue with the SQL is that its error message is not always intuitive. It's possible that the error message is completely different from what the error really is. It's unfortunately, this is the part of SQL, your life in SQL. So you have to check the whole SQL if you run into an error. Don't assume the error is what the error message tells you. Okay, and now we already seen that before just now. Length of a chart, value too long, because this one, I don't care which side I am in, is too long. And by the way, this double quote, this two single quote is how you write one single quote. So if I change this, is I don't care. It should work. Oops. I think I accidentally choose the wrong. Okay, it's still too long. This time let me run, it works. And let me see the instructor table. Oh, I need to refresh that. I forgot to refresh. So Postgres thought it was the same, was the old table. Now let me view the data. And Anakin Skywalker said, I don't. You can see that it is, oops, it is, I don't, one single quote. Whereas in our SQL statement, we use two single quote to tell DBMS that it is one single quote. Okay, now let me drop this. And there are some quick default scale. So once I create this table, default scale table, you can see that column one, how do I open this up? I will right click and choose table property. Inside table property, in the column tab, you can see that varchar is, there's no precision. Basically, it will goes to the upper limit allowed in Postgres, whereas the second one, the column 2, a char by default goes to only one character, right? So this is something that may cause some confusion you should avoid. Okay, so much is for the SQL that we have seen today.